Number 32 here wants us to take region A and revolve it about the line x equals 2, which they kind of already had started to draw for us right here. X equals 2 is this vertical line here, so our problem is going around that vertical line going this way. Okay, so what we're going to do is we're going to draw the 180-degree reflection of region A. And of course, region A is this one right over here. So let me just shade that in real quick. Okay, and when this thing gets flipped 180 degrees, we're going to get something that looks roughly like this. Okay, so this three-dimensional solid will be rounded here on top and bottom. There we go. And then kind of on the bottom, you'd see this rim here, kind of a difficult one to envision. Boy, as I look at it, what's left over if we were revolving region B here, and I think this might be what you're doing. No, I take that back. Not in any of those problems there, guys. It kind of looks like, actually, number 37 might have been this way. It looks like you're making a circus big top. What we have here is everything that's left outside of that. So, two big questions right here, guys. Which direction are we doing this thing? Is this a dx or a dy problem? Our slices always go perpendicular to the axis of revolution. This is going to be a dy problem. And the other question is circles or washers? Well, we've got all of this gap right here between region A and the axis of revolution. So with that gap, we're not flush against our axis. That means that we're going to be talking about washers here. So let's get rolling on this, guys. Formula for area of a washer is going to be pi times big R squared minus little r squared. All right, then we've got to do some work over here on the side coming up with big R and little r. Big R starts at the axis of revolution, and I'm going to go through the first curve and then all the way over to the second curve, and there's capital R. And what we can hopefully see there, guys, is that capital R is always going to be the same length here, no matter what its y coordinate is. It's a constant value. So what stops big R on the right? That would be here the line x equals 2. So 2 minus, and then what stops big R here on the left? That's the y-axis, which is x equals 0. So big R is just 2. Little r, though, is going to be a little bit more interesting. It starts also at the axis of revolution, but stops when it hits the first curve. So there's little r. So little r is stopped on the right once again by the line x equals 2, but then it's stopped on the left by this parabola, which is y equals x squared plus 2. Since we're integrating this with respect to y, we're going to need to solve this equation for x. And I believe there we're going to get x is equal to the square root of y minus 2. There should be a plus or minus there, but since it's the right half of a parabola, it's the positive square root that we need. So little r then is going to be 2 minus the square root of y minus 2, and there's nothing we can do to simplify that, guys. So that's where it's at. So area then, written as a function of y, is going to be pi, that was ugly, times capital R squared, that's just going to be a 4, minus little r squared. Ooh, and if it was just the radical, that would have worked out nicely, but with the 2 minus, that gets pretty tough. I should probably not overthink this. I should have probably made that a bracket, and now little r, I'll put in parentheses. 2 minus the square root of y minus 2, close off little r and square it. And I think that's as good as this a of y expression is going to get, everybody. So now that we know that, the rest of this should be pretty simple. Volume will equal the definite integral, and this one isn't too bad, so I'll write it out. I'll put the pi out in front, and then my integrand will be 4 minus 2 minus the square root of y minus 2, close it all, square it. We're integrating with respect to y, and our limits of integration are the lowest and highest values of y in this region. We're starting at 2, we're ending here at 6. Okay, so hopefully if I can type that into my calculator correctly, we should end up with the right answer here without too much difficulty on problem number 32. So time to run to the calculator now and make sure we're typing this one in correctly. So I'm going to put, here we go, the pi out in front. Let's go down here. I lost it. Where'd it go? There it is, pi. And then here we go, guys, menu 43. So an integral starting at 2 and ending at 6. Gotcha. And then our integrand, I believe, started with just a nice easy 4, and then minus 2 minus the square root of y minus 2. Okay. See how much of that we can get. So 4 minus, and then in parentheses, it was 2 minus the square root of, and I believe this one was a y plus 2. We'll get out of there and out of that set of parentheses, and then square all that. Ooh, did I get that right? 4 minus 2 minus, oh, those were all minuses right there, and I think I typed in a plus. Yes, I did. All right, that's why you always double check this, guys, and put a minus right there. Okay, I think we've got all that, and we're doing it all with respect to y. So let's see what the calculator tells us. 40 pi over 3, that's the exact same thing the solutions manual says too, guys. So we got it. Not too bad right there. So a 40 pi over 3, and we'll throw some cubic units at the end of that. So there's problem 32.